Okay, in the last section of today's lecture, we'll talk about ethic issues in large-scale pre-trained models. In the last section, we mentioned that there are robustness problems in current models. In addition to that, the model might also encode social biases. So how would the model encode social bias? There are multiple reasons. So two important sources are, first, the various prejudices and stereotypes in the text. Recall that the models are trained on large-scale text generated by humans, so naturally, it would also contain biases in human society. For example, it might say sentences like, "It was a very important discovery, one you wouldn't expect from a female astrophysicist." And this would make the model encode the gender bias. In addition to the pre-training text, our training data might also have selection bias, meaning that we have collected the training data from a specific source that may not have full coverage of the overall data distribution. For example, most current NLP benchmarks are in English, but natural language is not only English. There are many other languages out there, and because we train our models on mostly English, it may have lower performance on the low resource language. And here is one example of gender bias in machine translation. Here the input is an English sentence, which does not have grammatical gender. So based on the noun, the doctor, we cannot tell whether the doctor is male or female. But in some languages, there is grammatical gender associated with the noun, like in Spanish, shown here. So now when we translate from English to Spanish, based on the whole sentence, because it mentions the doctor asked the nurse to help her in the procedure, we know that is her refers to the doctor as a female. But the model would ignore that evidence and directly translate it to a male doctor in the target language, because that's more common or stereotypical. And next, in this example, we have text generated from the pre-trained language models. And as a warning, many of these examples contain inappropriate language. But just to illustrate the problem, here, given the prompt or the prefix the man worked as, the model generates a car salesman at a local Walmart. And if you change that to the woman worked as, it produces a prostitute under the name of Haria. So we can see that the text generated by these pre-trained language models inherits biases in the human society. And also, if we further fine-tune this model on downstream tasks, the bias may carry over to the downstream task even after fine-tuning. Okay, so what can we do here? First, bias mitigation is an active research field, but again, so at this point, it cannot fully solve the problem. So we cannot just rely on bias mitigation and trust our model. Instead, we have to be aware of potential harms of the system and try to test the model of different types of social biases. In addition, when releasing or deploying the model, we need to provide explicit statement of the training data used by the model, such as the language, the source of the training data, and the potential biases in the model. In addition to that, we should also state what type of system behavior is harmful, in what ways, and to whom. For example, does that exhibit gender bias or age bias or other type of biases, so that the customers or the users would be fully aware of what they're getting into, the potential harmful behaviors from the model. Okay, as a conclusion of today's lecture, the main topic we covered today is the self-attention mechanism and the transformer architecture, which is built on top of that. The key thing to remember about attention is that attention models dependence between two parts of the input. In recurrent neural network, we compute the encoding from left to right. In self-attention, we compute or model the dependence by computing the pairwise interaction among the words. And compared to RNNs, self-attention is an efficient way to model long-range dependence in sequence data because we can easily parallelize the computation of these pairwise interactions. And finally, as I mentioned, attention is the centerpiece of today's large-scale NLP models thanks to its computational efficiency. In the second part of today's lecture, we looked into the paradigm of pre-training and fine-tuning. Large-scale self-supervised representation allows us to learn good representation that's useful for many different downstream tasks. So thanks to this large-scale pre-training, now we can have a single model for many different tasks. And secondly, we also unified the learning paradigm, which is to take the pre-trained model and then fine-tune on downstream tasks, as opposed to develop specialized architectures for different tasks. But still, we should be aware that scaling up the model and pre-training do not solve all problems. And we have seen that the models are not robust to simple perturbations of a sentence, and it may also have various social bias problems. So we have to understand when the model works well and when it might have unexpected behavior or even harmful behavior to certain groups. Okay, that's the end of today's lecture on attention and transformer. I hope you have learned something new and enjoyed today's lecture. If you have further questions, feel free to reach out to our TAs or email me directly. Thank you.